Okay, let us discuss this problem. This problem is from Irodov. So problem number 1. So figure is 1.7. Problem number 1.53. So this is problem number 1.53. So let me first make the diagram and then we'll discuss the problem. So I have something like this. Then this is line, this is another vertical line. Now this is kept on a plane. Now what is said? A ball of radius r. So radius is given. Basically 10 centimeter. So radius r rolls without slipping. So this is rolls without slipping. So rolls no slipping. That is B is equals to r omega is satisfied. This says moves on down an inclined plane so that its center moves with a constant acceleration a. So center is moving with a constant acceleration a, and this is given in the problem 2.5 centimeter per second square. After t is equals to 2 seconds, so this is given t is equals to after 2 seconds. After the beginning of the motion, its position corresponds to the shown as in the figure 1.7. So after 2 seconds, its situation is shown in the figure. Here we have a point A, and this point is called B, and they are calling this point as O. So find the velocity of point A, B and O. So three things. What is the velocity of point A, velocity of point B and velocity of point O at t is equals to 2 seconds. Now see, now this roll is pure rolling. So this is a case of pure rolling. So this means this is moving in rotating as well as moving. After t is equals to 2 seconds, what will the velocity? So velocity of center of mass is given by v plus u plus at. Initial velocity, let's say this starts from the rest. So ball rolls without slipping down the inclined plane so that its center moves a constant acceleration after the beginning of the motion. So this means t is equals to 0 is given after the beginning of the motion. So beginning motion start at t equals to 0. So u is equals to 0 plus a is given into t. So t is given, a is given. Let us put this a naught and t naught so that we don't have any confusion that this is a. So now we know the velocity of center of mass. Now if you see, let us treat the velocity things. So first let us discuss point A. So this is my point A. At this point, center of mass has a velocity a naught t naught. So this point will also have a velocity, tangential velocity a naught t naught, because center of mass is moving. This means everything is moving with this velocity. Now due to rotation, this is also rotating. I can write due to rotation the velocity is r omega. So this will also have a velocity r omega. So this will have a tangential velocity r omega. This point, so point B will have, so all point will have velocity a naught t naught. This point is going down, so it will have a tangential velocity a naught t naught in a downward direction, because tangential velocity we know is given by the tangent. At this point this is the tangent, at this point this is the tangent, at this point this is the tangent, at this point this is the tangent. So you see at this point this will be a naught t naught. Now at this point tangent is in this direction, so tangential velocity will be r omega basically. So r omega here, and r omega should be equals to a naught t naught. That's why I have written here A naught T naught, because V is equals to R omega. So center of mass also has to satisfy B is equals to R omega. So BCM is A naught T naught. So R omega also has to be A naught T naught. So this is A naught T naught. This R omega is also equals to A naught T naught. This R omega, that is also equals to A naught T naught. Now you see the top point. Top point will have two velocity of A naught T naught. So this is A naught T naught and this is also a T naught. So the top point will have a velocity of 2 A naught T naught. What about B point? So resultant will be B1 square plus B2 square, that is A naught square T naught square plus A naught T naught square root. So this will be root 2 A naught T naught. Point C, that is obvious, this is A naught T naught in this direction and A naught T naught in this direction. So this is 0. Now come to the second part. This part says what is the acceleration of these points. Acceleration, so they are talking about acceleration. In circular motion we have two acceleration. So one acceleration is due to acceleration of center of mass and acceleration due to this motion. Now you see this is also this point. So if you see this particle, you can see, so let us say any point, this point there is acceleration of center of mass, so this point will have one acceleration component due to center of mass. Now this is moving in a circular orbit, this is moving in a circular path, so this point will also have acceleration, that is v square by r down, and one tangential acceleration a alpha. So we will have a alpha tangential acceleration, v square by r, that is the radial acceleration. So in the radial direction for this point, so you will have minus at this point. So let us calculate at this point. So let us say acceleration of b I want to interested. So acceleration of b a alpha, and in this direction acm minus, so in this direction, so let us say this direction is radial direction, so radial direction we will have acceleration of acm minus b naught square by r. Now acm is what? Acm is given in the problem, this is a, so this is a naught. So you see acm is given, this is a naught, so acceleration is a naught. After time t, what is v naught? That we all know. So we have already calculated v naught is nothing but a naught t naught. So this is a naught square t naught square by r. So this will be equals to a naught 1 minus a naught t naught square by r. Similarly, normal reaction, that is this side, this will be a alpha, where a is what? Basically radius. So this is r alpha, you can call it r alpha. Alpha is nothing but alpha, so this is my alpha. Alpha is nothing but d omega by dt, and omega is v by r. So let us put this inside. So if I take, so simply dv by dt, so I will have a tangential acceleration dv by dt. dv by dt I know this is same as a naught, acceleration of center of mass. So the total acceleration will be a radial component whole square plus tangential component whole square a naught square plus a naught square 1 minus a naught t naught whole square by r whole square under root. So this will be the total acceleration for point B. So important point is we have to find radial as well as tangential, and then we have to take the square root for both. So let's discuss the next part. Let us calculate the total acceleration at point. So let me take the next page. So use this page. So let us go here. Let us calculate at this point. So if I say at this point, so bottom point, so I will have one acceleration a naught is here, also a naught. Now a alpha, that is a alpha is nothing but dv by dt, and dv by dt is a, because this is a pure rolling case. A alpha will be, so this is a alpha, that is r alpha in this direction, and now v square by r in this direction. Now you see a naught is same as r alpha, so this component cancel out, so I can say tangential component for point C, this point is O, is a naught minus r alpha, and r alpha is same as a naught, so this is equals to 0. Now what is radial component? Radial component is simply v square by r, and we have already said that is nothing but a naught t naught. If you are writing your copy, you can see this is a naught t naught whole square divided by r. So this is a naught square t naught square by r. So this is the total acceleration for point O. That is simply v square by r. Now we have one more part, acceleration of point A. So this is the top point. So acceleration of point A. So I am also interested. So this is point O. We have discussed point O. Now for point A, that is the top point. Now top point, acceleration of center of mass is a naught. So this point will also have acceleration a naught. Are you getting or not? Now a alpha will be same. Now this is rotating in this way, so a alpha will also be in this direction. And a alpha I know this is equals to a naught. So r alpha is equals to, I know this is simply as a naught. So in this direction, and one acceleration we will have b naught square by r. So I can write tangential acceleration is 2a naught, radial acceleration is v square by r. Now this time velocity is v naught, and v naught we have already derived, this is a naught t naught whole square by r. So this is a naught square t naught square by r. This is more mathematics, less physics. Now so total acceleration will be 2a naught whole square plus a naught square t naught square by r. Are you getting or not? Now if you take a naught common, you will have 4 plus t naught square by r. This is a naught. Are you getting now? 4 plus t naught square by r. Basically there is a correction. You see here you will have radial acceleration whole square. So this is whole square. Now if I take common, because the sign is not, so dimension is not coming correctly, that's why I am looking for some error in the calculation. You see this is a square of radial acceleration, so this will come out to be a naught square t naught square by r. Now you see a naught t naught whole square, so divided by r square also, because a naught t naught is the dimension of length, so a naught t naught square will be dimension of length square, and if you divide by length square you will get the desired result. So you see in this problem what we have done, we have considered the different part of acceleration. You will have a radial acceleration, you will have tangential acceleration, then you have to add these two acceleration. You will have, you see, you will similarly will have two component of velocity, tangential velocity and radial velocity, and then you have to add. That is the important part we have to learn from this problem. We'll discuss the next problem.